I've been over here actually playing the whole time during these talks, the two short talks. Who does debugging in here? Great. There's more than three. Because I have the impression when Adam asked who did programming, like 3 hands went up, and Brendan and I were 2 of the 3 hands. So you guys do some debugging. So what I'm going to talk about a little bit is how you can use DTrace for debugging, and I'm going to show through some demonstrations. So generally, you know, I ask people, what's the best debugging tool? What's the tool you always use when you're debugging? And yeah, no one's of course going to answer me, but generally, the #1 tool people use for debugging is to put print statements in their code. Printf. I still use it. I use it all the time. It's easy. I'm used to it. So what's the problem with printf? Well, you got a routine that's getting called 1,000 times a second, and you got a print statement. So you end up after a minute of getting print statements, you've got millions of lines of output. Good luck. That's one problem with printf. What's another problem with printf? Well, another problem with printf is you stick print statements in to debug your code, and the problem goes away. Isn't that great? So your problem is solved. Just leave the print statements in. There's no bug anymore. And if you don't know what I'm talking about, well, you're the part that I asked if you did debugging, you haven't really done. So yeah, printf can change the timing of your code in such a way that the bugs mysteriously disappear. Okay. So what's another issue? Okay. So what do people usually do? You put if-else. Maybe you stick if that debug, you put your print statements in, everything's good, you've got all your debug output, you got your problem fixed. So what do? Maybe you do what I used to do, because one time I didn't do this. You rip the print statements out. I used to get print statements like crap 1, crap 2, just to tell me where I was on the code. And one time we got a call from a customer that said, I'm seeing crap all over my screen. So it didn't work too well. And so at any rate, maybe you turn the if-def off. Because everything's fixed, it's working fine now. 6 months later, your customer calls up, we got a problem. So what do? Well, you turn your print statements back on. And then you send it to the customer, and of course, the software you sent them didn't match the software they were running, and they're not seeing the problem. Or the customer says, it's a bug, but it's running. Well, just put in this new version. Well, we have to turn off the old one before we can run the new one. Well, yeah, we have to do that. And the customer says, well, we've got scheduled downtime. I think it's in March of 2017. So we're going to wait with your stupid bug because you can't fix it. So what does DTrace do for all this stuff? All right, so one thing it does, generally, I mentioned you put print statements in. What do you print more than anything else? You enter the routine, you say, I got into the routine, these are the arguments. You print them out. And then when you return, maybe you print out the return value, and maybe you print out where you're returning from, and you've got multiple places you're returning. Okay? So with DTrace, nice thing about DTrace is you don't have to add a line of code. You can get that information. So I've actually been playing with this program I wrote several years ago, and I thought maybe I could go through a couple of examples with this. But basically with DTrace, your customer says, I've got a bug, and instead of saying, oh, let me ship you a debug version, which doesn't really match the version you're using, instead you say, here, run this DTrace script, because it'll give you the debug output. You didn't change a line of code, their code kept running however poorly it was running, and now you've got some output you can take a look and see what's going on. So that's my whole talk. Now I show a bunch of demonstrations. All right. And oh look, you can't see what I'm looking at. How do I get this up there? I have a new laptop. I just got this today, and I keep thinking I'm gonna see something on here that's gonna say, "Oh, display on the screen." All right, so a couple examples. So one thing you want to do is let's just say you want to see the arguments of some function. And I'm going to pick some general function that everything calls just to print it out. Is there a way to change the resolution? Yeah, how do you use these? Let's try. Now, of course, I'm doing this on the shell, which isn't doing anything, so let's pick some other bit. I might have another shell on here. 2914. Okay, so it called string length, and it called string length on what looks to be my prompt. So I'm just showing you see the function getting called, you can see the argument that's called the function. If there's multiple arguments, you can see that. I'm going to show something else you can do with arguments in just a few minutes. You can actually print out structures, and instead of having to sit there and type printf for every single field, it's really simple. And maybe I show that now since I've already mentioned it. Okay, so this little program ran IO64. I wrote it, like I said, a few years back. I play with it every once in a while. It does random IO, or tries to do random IO. I'll show you something you can use to kind of try to figure out, is it really random? At least it's evenly distributed, or reasonably evenly distributed. So I'm going to run a little script on RAN-IO. So what I'm doing here is I'm starting up this RAN-IO program with some arguments. Uppercase R basically says do reads and writes minus S8192. So we're going to do 8K reads and writes at a time. And I'm going to do this on this 410 big file, which is a 10 gig file. It's actually all wall. And I'm going to do this 100 times. So I basically do some number of iterations through the file, and I do it 100 times. And ram D, oh, I gotta show you this. So this is a little DTrace script, but I pulled in parts of my C code. So maybe I asked before who did programming, and of course that meant C. Maybe it meant Java, C++, Ruby, Erlang. JavaScript, of course. And I'll talk about Node, but very briefly at the end, because it's worth bringing up these other programming languages as far as DTrace is concerned, because you can use DTrace with these other languages. But I'm sticking with C because that's what I learned as a little guy, and I still like it. What's that?
DTrace is not on Linux right now.
DTrace is not on Linux. Well, see, Brendan is that going to be a yes? Yeah. Brendan's going to actually talk about DTrace on Linux. So you guys, and how do you know this is Linux? By the way, you couldn't tell from what I'm doing that this is not Linux. But I'll tell you one thing. The only thing you can tell is that it probably isn't Windows. But okay. At any rate, so there's a function. I'm going to show the function first. It's called doIO, and it takes this argument, which is a pointer to a data structure. And what I'd like to do is, when this gets called, I'd like to see what is in this argument. What is it? So what I do, I take the data structure for the argument, which is this thing here, this IO harm structure. And I pop it into a DTrace script, just cut and paste. And then whenever this function gets called, I'm going to print this data structure. Now I'm not going to go into why I'm using copy, and R0 is the data structure I want to print out. See, the nice thing about this is that I don't have to change the code. I can do this while the code is running. And it will have a minimum amount of impact when I'm using DTrace. And when I am not using DTrace, there's zero impact. And how does it do that? Well, it does what a debugger does. When you set a breakpoint, it patches an instruction. So you went from a routine, you just change the first instruction to a routine, you get trapped in DTrace. DTrace does the same and returns control back to the program. It's really simple. I'm simplifying that too much. I said this once to Brian, it's really simple, and Brian said, yeah, it's simple, and it took how many years to write it? Well, I didn't write it, I can explain it, and it's pretty straightforward. Although, I should mention I'm working on adding a new action to DTrace so that you can dump binary data, and then you start to learn, well, it's not quite so simple. At any rate, let me go ahead and show you this in action. Yeah, so I'm going to go ahead and run this. And so I run the script, and there's my data structure, all the fields, boom. And if this was a kernel routine, I don't even have to, I don't have to add this data structure to my DTrace script. I just basically can access it. But I decided I'd stick to user level stuff because nobody does the kernel anymore. And no one's interested, actually everyone's interested, but no one really. There's a few people that do it, they like Adam, and Brendan. I'll do it occasionally. So anyway, you can trace entries into function calls, you can print out arguments, you can trace return values, where you're returning from. So what are the kinds of things you do? Well, one of the things we did, so joining, we ported KVM from Linux to SmartOS, which is basically our version of Lumos. And when we did the port, I started doing the port, And I'm kind of lazy. I said, I want to get this just to work. And when I did this, KVM, in the kernel, KVM is between 17 and 28,000 lines of code. I don't remember how many. But there were things in the code I said, I don't think I need this just to get it to start up. So what I did was I started putting XXX, if def XXX, skip this code. I did this all over the place. A time on skip this code because I don't think I need it right now. Brian took a look at this because Brian and another guy, Robert Stuckey, they joined me and they said, Brian said, what if we hit these XXX? We don't even know it. So he put in pros. So think if def debug. But here we have XXX. So wherever there was an XXX, you put in DTrace probes, and you can turn the probes on. So whenever we hit a bug, you turn the probes on for all the XXX states, and then you look to see what you hit. If you hit something, if you hit the probe, big trigger, it meant that there was an XXX code that should have been executed, but wasn't because it was commented out. You guys with me on all this? A little bit more. Yeah, just one more thing about the printing stuff. It is like using printfs, debug printfs, except you have much more control over what you print. You can do these things called aggregates and aggregate so that if you get thousands of lines of output, you don't have to actually print thousands of lines of the same thing. You can print return values. And I left it was one of the things I wanted to talk about, but I left my notes over here. Does this still work over here? Oh, okay. Let's see. Print out the data structures, print return values. Oh, yeah. So there's a couple other things that could be interesting. Adam, you showed the stack traces. So that everyone understands. So with stack trace, one of the things you can do is, when you get a bad argument, you've got a function and you know that the argument coming in is a null pointer. Why is it null? How did I get here? You dump the stack, so you can actually look for the more, and when you see it, dump the stack out. Usually, that gives you a good idea of where to look. If I'm getting a null pointer, who's the caller? What was the code that through that? So, no, I don't need to show that, but it's another debugging thing. Okay, there is something else you might do. So, stacks tell you how you got from the beginning to where you are. What if you're at some place and you want to know what happens from here? Adam, I'm sorry, you did not show the flow intent, did you? Okay. So this looks something like this. What should I fix? So what this is going to do is whenever I run into this routine in the kernel called ZFS_right, I'm going to trace everything that happens from that point until ZFS_right returns. And this might give me lots of output, but we'll do it anyway because I've already started. So now, of course, there's nobody doing any writes. Let me write something. And what this is doing, so it shows me, okay, so I entered ZFS right, and then ZFS write called UIO pre-fault pages, which called trap called new state, blah, 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 blah. So what's nice about this, you're sitting here looking at this going, when would I ever use this? Okay, your job is now, you have to maintain a piece of code that's 1 million lines long. So what do? Oh, you sit and read the code. Good luck. What this will help you do is it'll help you focus on what you need to read. Because it narrows down. Okay, I don't need to look at this. It's not getting called for this particular area. So it can help for debugging again. At least that's my rule. Okay. What else? There are what are called these providers. So I've been using them without talking about it because there is documentation, there's actually videos, there's blogs, plenty of people have written about DTrace. So I'm not really going into the syntax or anything of using DTrace. I just want to get the idea that this is a really useful tool for debugging. Maybe Brendan will talk more about it for performance monitoring, and it's fabulous for that too, of course. It's a great tool if you start using it. Yeah, you'll say, how did I get by without this? You know, for years, I teach, Unix internals courses. And for years, I had no access to source code. And what I did is I had a debugger. And I would do things like set a breakpoint in single step to figure out what the heck, what was going on. Then all of a sudden, source code, and then DTrace. It's a reverse engineer's dream. You don't need what we still need to reverse. It's not easy, it's a lot of code. You can sit there and try to figure it out. Good luck. This can help. Okay, so what else do I want to cover up? Node, higher level languages, Java, Perl, Python, Ruby. There are DTrace providers for these. So in other words, you can, for instance, and no, I'm not going to demonstrate this, but you can do things like take your JavaScript and put probes into your JavaScript so that you can debug it. All right. Now,
is that because you need that to get it to be a provider of features?
you need.
I thought the benefit of DTrace is that you don't have to go in and modify.
Okay. It depends on what you're doing. Okay, but with I don't even know the terminologies. Okay, I don't know these languages. With Java, a script or a Java method, it's interpreted. DTrace can't just blindly know about that, about what the script does. So you have to actually say something. There are probes for instance, the node engine, the V8 engine. So you can actually monitor HTTP requests from client, server request, server response. You can monitor those. So they're built into the node engine, but in script, it's an interpreted language. Okay. Let's see. Let's do something else. Yeah, now, Brendan, should I do this, the trust one? I'll show people how does this zero overhead stuff work. And I mentioned it already, and I'm going to show you real quickly now because I can, because I've got you all here, and you've all eaten pizza, and now you're falling asleep. So, you're not going anywhere until I kick you out or something. So at any rate, what I'm going to do is just to give you an idea of how this works. So this is a routine called page fault. It's in the kernel, and you see it does the normal x86 type stuff, and this will not look that different on other operating systems. They all do the same thing, create a new stack frame. Okay, so while this is going, so I'm not doing anything, just looking at the code right here, what I'm going to do is trace page faults. So this is going to trace faults and the page faults. And there's some page faults happening. What do you know? And I can give more information about those, but I don't really care about those right now because I just wanted to show you. So what is DTrace doing? And what DTrace did was it took that first instruction to push RBP, shoved it someplace in DTrace keeps, and changed it to a track. It's zero overhead when you're not using it, because if I go back and kill the DTrace, I can get back to that window. And if I look at the code again, it's back to where it was. So in general, this is the way the probes work. If you instruments, you can't add probes. I think Adam might have mentioned, or Dan might have mentioned statically defined traces, or maybe I heard that before the talk began, but you can't add your own probes, and adding your own probes, what basically happens is when DTrace is not being used, when you're not turning on those probes, they're just a couple no-op instructions. You turn the probe on, and the no-op gets replaced with basically the same thing, trap and DTrace. Kill the DTrace, the trap goes away back to the no-ops. And in the case of these probes, this probe that I'm looking at right here, and this is most of the kernel, user level functions work the same way. So when I trace that do IO function, it just changes the first instruction to trap and DTrace. Well, I think the idea is just, it's so obvious when you see it. Oh, of course, this is what a debugger should do. When you set a breakpoint, it should hit the breakpoint, it should do whatever it needs to do and come back. That's it, we're doing it. All right, now. Oh yes. So, here. All right, so what I'm going to do is, just to give you an idea of the amount of overhead, so this is basically going to do, it's going to time DD from dev 0 to dev null. This will do basically fill a byte, a 512 byte buffer with nulls, and write it to null. And it's going to do this 1 million times, and then time it. Here we go. Good. About 2 seconds total time. Now, I'm going to do the same thing. I'm going to use truss. And for those unfamiliar with truss, you probably have heard of strace. And if you go and read source code for strace, you'll see that it came from truss. I'm going to time this. How long does this take? And the -C option is just going to give me some counts. Just a little bit of statistics. It's not actually going to give me literally millions of lines of output that a normal truss would in this case. Just kind of a summary. And we'll let this go. And I'm not sure how long this will take because I did this on my old laptop. This is a brand new today. Isn't that cool? That's why I'm going to get a new laptop. And I think on my old laptop it took about 1 minute and 20 seconds. And I'm going to do this. While this is running, we're going to do the same thing. But instead of using truss, I'm going to use DTrace. Okay, so 30 seconds. Wow, my new laptop is dead. That's right, it's twice as fast, twice as much memory. It's half the size. It's fabulous. Okay, now. Oh, wait, I'm not teaching an Apple. I'm not talking about it. Sounds like I am. All right. Let's do the same thing now. But instead of truss, I'm going to use DTrace. will basically give me the same information. I'm not going to quite get everything because I'm lazy, but basically the same information with counts of the function calls, of the system calls being made. Okay, so no tracing at all, 1.8 seconds. Trust or strace, 30 seconds. So we're 8 times faster using DTrace. Same information. All right, and